Welcome back. In our last video, we began to explore number variables in Python. We looked at integers, and we talked about the difference between integers and floating point numbers. Integers being whole numbers, numbers with no decimal or fraction, and floating point numbers being numbers that do have a decimal, even if there's just zeros after the decimal point. So the number 4 is an integer. The number 4.0 is a floating point number. In this video, we're going to explore floating point numbers a little bit more, and how integers and floating point numbers interact, and how you can convert between the two, how to move from one to the other. And one of the first things I want to show you all, and the book doesn't go over this yet, but there is a way to check which kind of number you have in a particular variable. And that is by using the type function. So type, T-Y-P-E, and then you put a parenthesis and you put the name of your variable. And that is going to give you what your number is. And so we can put this in a print statement and print out what the type of our variable is. So again, this is going to tell us if it's a floating point or an integer. And if we run this, you'll remember that, well, why don't we try switching back to just an integer to begin with. So first number equals 2, and we will print type first number. And you'll see down here it says class and then quotes int, and so that's telling us that the class of variable that we have is an integer. All right, well, what about if it's a floating point? So we'll switch this to 2.5, and when we run this down here, it'll say class float. Okay, so what about if we do say some division, 2 divided by 2. First number equals 2 divided by 2. And hopefully you remember from last time that even though that the answer is going to be 1, because we're using that single slash division, that's floating point division, it's going to give us an answer of 1.0, a floating point number. And so this should print out class float. Let's try running it, and sure enough, it does, class float. Okay, what if we do integer division, 2 /2? The answer should be 1, but we're asking it what type we have here, and it will say class int. Okay. Now, another thing that we can do is if we have a floating point number, we can convert that to an integer by using the int function, int, and we put what we want to convert in parentheses. So here, what we're doing is we're doing 2 divided by 2. That's going to give us 1.0, a floating point number. That will be then passed to the integer function, and it's going to convert that 1.0 to the number 1. And let me print out not only the type, but actually what the answer is. And so down here in the output, when we run this, we see class int, and the answer is 1. Okay, what about if we have integer division, say 4 divided by 3? So the answer would be 1.33 repeating. When we run this, it's going to truncate again. It's going to drop the decimal and only give us the number 1, just as if we had used integer division. So even if it would be closer to rounding up to 2, It's just going to drop everything after the decimal place and give us 1. All right, what about if we want to go the other direction? We can do the float function to convert from an integer to a floating point number. So say we have 17 and we want to convert that to a float. And we see when we run this, it prints the type and it says this is now a floating point variable, a float, and the number itself is converted to 17.0. So we have two different functions to move back and forth from integer to floating point. Okay, well, what about if we have a string? Say we have the number 17, but it's in a string, in quotation marks. What can we do with that? All right, so when we run this, you'll see class is str, so that's the type of data in our variable. It's a string, and when we print it out, it's just printing out 17 with no quotation marks. So in output, you wouldn't be able to see any difference between a string of 17 and an integer that is equal to 17. When you print both of those out, they're going to look exactly the same. But they aren't exactly the same. So one of the things that we can do is that we can, see if this works, convert a string to an integer using int. And sure enough, that works. So class int is the output and the number 17 prints out. Okay, so what about though if what we have in here is not an integer? Say our string is my name. What's going to happen? Well, we're taking something that's not an integer and we're trying to convert it to an integer. And when we do this, we get an error. So down here, the error, it highlights int Todd Dole, and it says invalid literal for int with base 10 Todd Dole. In other words, this is not something that you can convert to an integer. This is not an integer value, and so we're unable to convert it. All right. So down the road, we're going to learn how to handle that and how to prevent errors like that from occurring. But for now, you should know if we say first number is equal to input, please type in a number. And then that is always going to give us a string. So the input result is always going to be a string, even if somebody types in a number. Let's try running this. All right, so down here it's running. It says, please type in a number. I'm going to type in the number 17. And we see that the class of our data is string. Even though I typed in an integer number, anytime you input from the keyboard using the input function, it's always going to put the result in a string. Well, what if we want to convert that then to an integer? We can do first number equals int first number. And so what we're doing here is we're saying take first number, convert it to an integer, and put that integer in the variable first number. Okay? So we run this, and it's going to say, please type in a number. Let's put in 25. Let's even try with a floating point number, 25.5. What's going to happen here? All right. So that's going to give us an error because the number that's in the string is not an integer number. What if we put in just 25? So that then works. It runs successfully, It converts it to an integer, it places that integer in first number, and then it prints out that first number is an integer and the number is 25. And so we do at times have to do some validation of what kind of data we have, especially if we're taking input from the user. Down the road we're going to talk about how to do this, but just for now, know that if you are creating programs where you're typing in numbers, you want to be careful that you actually type in the kind of number that you want. Now we can do this with a float as well. So if we say please type in a number and then convert that number to a floating point number, let's see what happens here. So we'll type in 25 again, and we see it converts it to 25.0, a floating point number, and prints it out. So no problem there. What about if we type in something that does have a decimal, 25.5? So again, that's going to put 25.5 into a string variable, and it's going to place that string in first number, and then it's going to take that string and try to convert it to a float. Let's see what happens here. And when we run this, it is successful. So please type in a number, 25.5. It converts it to a float, and it prints it out as a float. Now, one more interesting thing that you can do. Remember that when we were converting it to an integer, if we tried to put in something like 25.5 and convert that from a string to an integer, it gave us an error. But remember that we can convert 25.5 as a floating point number to an integer. And so there is a way to kind of get around this if we want to be able to take input and we aren't sure if our user is going to give us a number with a decimal or a number without a decimal, but we want to convert it to an integer either way. We can actually convert it to a float first and then convert the float to an integer. And what that will do, say we run this and we put in 25.5, it's going to take that 25.5 here and it's going to convert it to a float here. So the float would be 25.5 as a string. Oops. I'm just typing in the values of what it will be at each point. So initially it's a string 25.5 in quotation marks. Then it converts it to a float 25.5, and then it converts that float to an integer by just dropping the decimal point, so to the number 25, and that's what ultimately gets printed out. So there is a way to get around that, and we will see. Let's try running it again. If we put in just an integer, it's going to be able to handle that as well, because it'll convert that string 17 to a floating point number 17.0, and then in the final line it'll just truncate that to 17 and give us the integer. So that is a little bit of a way to handle if you're not sure what the user is going to type in, but you want an integer, you don't want the decimal point, you can do a double conversion like that. But we should note it's still not going to work if they type in a name. Please type in a number, Todd, and we get an error. Now what about if they type in something that has a number in it, say Todd 17? Still is not going to be able to convert that to a float or to an integer. And maybe this is obvious, but just for those who are especially new to programming, one other thing you can't do is type in the number 17 and expect it to convert that. So it doesn't know how to take numbers typed out and convert that to a floating point number. All right, so hopefully that is helpful. A few different ways to convert. Let's talk a little bit more about the interaction between integers and floating point numbers. So first number is 17. Second, let's add a second number is 2.0. And then we'll say third number equals first number plus second number. So here we're going to take an integer and a floating point number, and we're going to add them together. And let's see what the type of the result is. So we're going to print out the type of third number, and then we'll print out the value of third number as well. When we run this, so it's going to take 17, it's going to add 2.0, and because one of these numbers is a floating point number, the result is going to be a floating point number as well. Oops, I scrolled up here. So looking down at the bottom, we see the class of third number is float, and the answer is 19. What about if we've got two integers and we do the same thing, 17 plus 2? It's going to give us an integer and 19 as our result. Right, so the general rule of thumb is that if you do any kind of addition, multiplication, subtraction, division that is including a mixture of integers and floating point numbers, the result is always going to be a floating point number. The only exception to this is if you use that double slash integer division operator, it is always going to give you an integer result. So here 17 integer divided by 2 is going to give us, of course the answer would be 8.5, but it truncates the 0.5 and just gives us an integer 8 as the result. Right, what about exponents? Again, if we raise the first number to the power of the second number, so this would be 17 raised to the power of 2, or 17 squared. It is going to give us a floating or an integer result because both of them are integers, and there's no need to convert it to a floating point. But if we do 17 raised to the power of minus 1, what's the square root of 17? The result of that is going to be a floating point number. And the square root of 17 is 0.05. That's not actually the, 17 to the power of minus 1 isn't the square root. I'm sorry. Misspoke there, but 17 raised to the power of minus 1 is 0.05. So that would be actually the logarithm, not the square root. Okay, there is a way to do a square root. We'll cover that in an upcoming lesson. Right, so hopefully you understand now how to convert between floats and integers, how to use floats and integers, how the two interact. One final thing I neglected to mention last video, I meant to include it, is that when it comes to order of operations, you can override the order of operations by including parentheses. So remember we said last time 1 plus 5 times 8 is going to multiply the 5 times 8 first and then add the number 1 because multiplication takes precedence over addition. But if we wanted to add 1 plus 5 first and then multiply that by 8, we can put parentheses around this just like you would in math done by hand. And that's going to do 1 plus 5 equals 6. 6 times 8 is 48. And the result will be 48. Okay? And again, if we throw any floating point number anywhere in here, even if it's a whole floating point number that could be converted to an integer, it's going to turn the whole thing into a floating point. So our result here is 48.0 and class is float. So you can do, you can nest these as much as you want. Say we do 1 plus 5 times 8 divided by 32, integer division. So that would do the inside parentheses first, the outside parentheses second, and then the integer division third. And the result would be 48 divided by 32, but it's integer division, so it's going to truncate, and so the answer will just be 1. And this is interesting that it actually, even though we're doing integer division here, it actually gave us a result that is a float. And let me see. Yeah, so one thing I forgot to mention is that when you're doing integer division where you're including floating point numbers, it's going to give you an integer result in that the number after the decimal is going to be truncated, but it's still going to give it as a floating point number. And so if you want to actually have an integer as a result, you would have to convert it to an int. So let's try this, and here the result, class integer, the result is 1. But if we don't do this, even though we're using that integer division, 48.0 integer divided by 32, it's going to give us the answer as a floating point number because we're mixing floating points and integers in our expression. Okay, so hopefully that was clear and y'all understand kind of how it all works. This is something that I encourage you just to play with, to do some experimentation with, maybe try to figure out how to do some calculations from maybe one of the math classes that you're taking, or for you engineering students, some engineering calculations. Throw some different expressions in there, some different calculations, and just see how Python handles it. The best way to really get a handle on this stuff and master it is just to play and experiment and try different things out and see what the results are. So encourage you to do that, and coming up we're going to have a second programming challenge that I'm going to give you in the next video, a little program that you're going to put together to do some basic calculations and put some of this in practice. Thanks. We'll see you next time.